Okay, guys, so let's start. Okay, guys, so last time I started to explain what we mean by decimal to binary conversion and binary to decimal conversion. So I started it, so I want to complete it today. So let me go to it. Yeah. So here, let me simply tell you what is the story. The story is, as you know, if you have like something like 1, 1, 1, 1, 1, 1, 1, 1, so this means 255. Also, if we have 1, 0, 0, 0, 0, 0, 0, 0, so that means 128. Is that okay? The problem is this is the system humans use. So we use this system, humans. However, when you get a number from the computer, you are going to get it binary. You are going to get a binary number. Same thing, if you want to send a number to the microcontroller or to the computer, you have to send the number in binary. However, when you get the number from the user, you are going to get in decimal. You understand what I'm saying? So I need to translate here. So if I want to show you, if I want to display, something here on the LCD, it has to be in decimal. However, I'm not going to get it decimal from the microcontroller. I'm going to get it binary. That's why I have to do some operation here to convert the binary here to decimal, okay? To show it to a human. Same thing, if you ask the human to give you a number, okay, using the keypad here, a human is not going to give you the number 101001. No, it's going to give you a number something like this one. That's why you need to convert decimal to binary so that microcontroller can take this number and can use it in your program. So I have finished, or I already have explained how can you convert binary, and even you did that in the last test. You did that. How can you convert a binary to decimal? In other words, be more specific. In other words, if I give you this number, how can you get these ones? Okay, how can you do that? Or if I give you this one, how can you get this one? Is that okay? And I told you the ideas. The idea is very simple. All what you have to do, you have to divide by 10, right? Every time you divide by 10, you are gonna get one digit from right to left. Okay, or one digit this way. For example, if you divide 128 as binary, if you divide it by 10, the quotient should be 12. However, the remainder is 8. So I got 8. Okay, now get the quotient again and divide it by 10 again. So when I divide this one by 10, so I'm gonna get a quotient and then I'm gonna get remainder. The quotient is 2 and the remainder is quotient is 1, remainder is 2. Okay, so here I got the second one. So first I'm gonna get 8, then right to left as I told you, then I got 2. Now if you already know that the quotient is only one digit, so you are done. Otherwise, if you don't know, how I don't know, you can check, you can know, but another idea is that you can keep dividing until the quotient is 0. You get what I'm saying? So if I get this one and divide it by 10, now the quotient is 0 and the remainder is 1. So once the quotient is 0, that means I am done. I don't need to divide again. Is that okay, guys? And then, so what I'm saying now, I'm gonna get digits. So I'm gonna get 1. I'm gonna get first 8, then 2, then 1 digit, right? Then once you have digit, as we did in the test, you can convert this digit to 7-segment code and use them, okay? Or you can convert them to Ascii code and send them to the LCD, but you have to convert them to something, right? Either Ascii code to the LCD or 7-segment code if you want to send to the 7-segment. Is that okay? So that's what I explained last time. Also, I explained to you, also, this is the main idea. You have to keep dividing by 10. However, also we have some functions. You know, functions, you need to understand the fundamentals. So you need to understand how it is done. However, if we have functions can make programming easier for sure. Okay, I hate teaching. When I teach you, I just give you a function and I don't tell you how it works. Just use it, it's gonna solve it. Okay, I hate that. You should understand how it works. However, to make programming easier, I can use functions, but still you need to understand how it works. And that's what I did everywhere in the course. When I teach keypad, when I teach LCD, I told you just use functions, but still you understand how these functions work. Okay, so here we have also several functions here. You can use this function to convert the binary to decimal. So one function I explained here last time in C language. In C language, we have this one. Type LCD. Okay. I'm sorry, not this one. Sorry. We have here. So here in this program, I show how can we keep dividing by 10 until the quotient is 0. That's what I have just explained now. Because look here, in the test, okay, I know that the decimal number I have, it's only 2 digits. That's why I need to divide by 2. However, sometimes I don't know how many digits are in the number. Okay, it can be 3, it can be 4, it can be 5. I don't know. Okay, in this case, you can keep dividing by 10 until the quotient is 0. So when the quotient is 0, okay, you can. That means you're already done. Okay. Anyway, so this is the idea. Here, I told you also in C language, you can do the same thing in C language, like what you did in the test. But here, you have to use percent to get the. For example, I can say here number. Percent 10, and this can be digit 1. Okay, so this is remainder. So I'm gonna say remainder of digit 1. But if you want to get the quotient of digit 1, you can use the normal division. Okay, this is the normal division. However, if this one is float, so you're gonna get something 10.2 or 7.7. Okay. However, if this one is integer, you're not gonna get this part. Okay, so it's gonna be like the quotient. Okay, anyway, so you can do this way like assembly, or we have some functions you can just use. Okay, so the function as I explained last time is here, write integer to LCD. That's it. Okay, and then put the number here. So we have write integer LCD, and we have another one, write long to LCD. It depends on how big is the number. So this function is really very interesting. You know why it's very interesting? It does too many things. This function, by the way, this function number 1 is gonna divide by 10 to get the digits. This number 1. Okay. Number 2 is gonna convert the number to Ascii. Okay. Number 3 is gonna display them on the LCD. You got what I'm saying? So everything in one function. Okay. As long as you understand how it works, that's okay. I don't want to make programming difficult, but you need to understand just in case you want to modify something, right? So anyway, so this one can work this way. Just you can here, you said, as you see here, I set the location. I put the location of the cursor, and this one is gonna write from this location. So if I put the cursor here, so you are gonna start writing the number from here. If I put it here, you are gonna start writing from here and so on. So here I did it this way here. This is a variable. I define this variable here. Okay. It does not need to be global. I don't know why I made it global, but you don't. It doesn't need to, or does it need to be global? I think no, it doesn't need to be global. I think if you put it here, it should work normally. Okay. Anyway, so this is I have also another functions I'm going to explain right now in assembly. Okay. So these functions, when I come here, yeah, they are here. So this already, as you see here, these are just the subroutines in the file we include. Okay. So you can look at these functions. So we have here this one converted decimal to binary. I'm going to explain it right now, but let me talk about this one. This one converted binary to decimal. This function for for assembly language. What this one is doing is we have 4 cases actually. We have 2 cases for 8 bits. If the number you want to convert is 8 bits, we have 2 cases for 16 bits. Okay. We have also 2 cases if the number is signed or unsigned, signed or unsigned. Is that okay? By the way, how it is different? You didn't. So 8-bit or 16-bit, that's very easy. How big is the number, right? That's very easy, right? However, signed or unsigned, how it would be different? I'm gonna tell you how it would be different. Listen to me, okay? The way, if the number is unsigned, okay, so it is okay. You just keep dividing by 10 as I have just explained. It's okay. Same thing if the number is signed and the number is positive. Same thing. You can just divide by 10 and that's it. Is that okay? However, if the number is negative, you should not divide by 10. I give you example. If you have here 1, 1, 1, 1, 1, 1, 1, 1, okay? If you divide by 10, you are going to get 255, which is false. As you know, this number is -1. If this number is signed, so this should be -1. So what should I do if the number is signed and negative? Okay. All what you have to do, you have to calculate the 2's complement of this number. So the 2's complement of this number is 1, and then you convert this one. So you divide by 10. So you have to convert the positive version. However, you have to start with negative. So when I convert it, I'm gonna get here the positive version, but I already know this is negative. So I have to start with negative here. You understand what I'm saying? Anyway, so as you see here, we have 4 functions, 2 functions for 8 bits and 2 functions for 16 bits, 2 functions if the number is signed, 2 functions if the numbers are unsigned. How this function work? Very easy, very simple. The way it works is, if your number is 8-bit, so you have to put this number in register B. So before you call this number, before you call this function, the number you want to convert, put it in register B. So this function should convert whatever in register B. For 16-bit, so here it has to put it in register D. Is that okay? Before you call the function. Okay. So number 1, the number you want to convert, put it in register B or D. This number 1. Okay. Number 2, you should, it depends on the type of the number you have, signed or unsigned. You have to select this one or this one or this one or this one. Okay. Number 3, what this function is going to do is, this function is going to convert the binary here to decimal and then to Ascii. So decimal numbers and then to Ascii, right? And then it's going to put it in array. For example, if I give here 1, 1, 1, 1, 1, 1, 1, and I select this one, unsigned 8 bits. So this one should convert it to 255, right? So it has to be 255. However, it is in Ascii, right? So this one is going to convert and also make it in Ascii. Also, it's going to put a delimiter here, which is 0. Is that okay? Who's going to do this part? The function. Okay. So once you call the function is going to take register B or it's going to take register D based on which function, and it's going to make array, right? But where is the location of this array? Is that a random location? No. You have to tell the function where is the location of this array. That is why before you call these functions, you have to put the starting address in register Y before you call this function. Is that okay? So here, Y point at the beginning of the array before you call this function. So this function is gonna store the numbers, decimal numbers in Ascii, starting from Y. Is that okay? And it should put delimiter 0 at the end. Any questions? And if the number is negative, so this function automatically is gonna put here the Ascii of negative here, automatically in the array. Okay, guys, very simple. So now what I'm saying is that we have 4 functions, as you see here, to convert the binary to Ascii, to decimal and then Ascii. Okay, and then when they convert it, they are gonna put it in array. Okay, so that you can use this array later. You remember, as you will see right now, you can take this array and you can send it to both string LCD. Both string LCD. Okay, you can send it to both string LCD as you remember. I explained this one before to display it on the LCD. You will see right now. You will see that right now how subroutines or functions can make programming much easier, as you will see right now. Okay. Anyway, so this also the subroutines we have. Any questions? That's all what I have. That's all what I have regarding how can you convert a binary to decimal. Any questions? Okay. Now I'm gonna do the opposite. Okay. You are gonna ask the user, please enter a number. You are asking the user, please enter a number. So now you are gonna use the keypad to get a number from the user keypad. Okay. For example, for example, I'm gonna enter number. I'm gonna enter, for example, 31, 32, and then 38. Okay, so that's what I'm gonna get from the user. So I'm gonna get that's what I'm gonna get from the user. Okay, so number one, which is very easy, you have to convert the ASCII to a number, which is very easy. All what you have to do, you have to subtract 30. You have to subtract 30. So now I have three numbers, 1, 2, 8. Is that okay? So now, given 1 to 8, how can you convert it to a binary number, which is, okay, we have four zeros here. Okay, another 0 here. Okay, so how can you do this conversion from here to here? Is that okay? So I'm going to tell you how. Very simple. Look, the idea is very simple. Look here. Number one, if you already know how many numbers you have, for example, here, you remember in the second grade, in the math of the second grade, they told you this should be in the ones, right? This is in the tens. This is in hundreds. Is that right? So the weight of this one is 100. The weight of this one is 10. The weight of this one is similar. When you convert to binary, you say 2 to 0, 2 to 1, 2 to 2, 2 to 3. Okay, same thing, because every digit has a different weight. It's the same thing here. Okay, so number one, if I already know how many digits I have, so what I can do, very simple. All what I'm gonna do, guys, is I'm gonna get this number simply. I'm gonna multiply by 100, right? So I'm gonna multiply this number by 100. Is that okay? And then I'm gonna get this one multiplied by 10, right? And then this one, you should multiply by 1, but no need, because multiply by 1, you are gonna get the same number. So I'm gonna multiply every number by the weight, right? And then I'm gonna add everything together. Now I'm gonna get 1 0 0 0 0 0. That's it. That's it. You got what I'm saying? So this is the easy way, the straightforward way. So the easy way or straightforward way is, if I already know I have, for example, three digit or 2 digit. If you have 2 digit, like for example 7 2. So simply I'm gonna take this one multiplied by 10, and then I'm gonna add this one, right? If you have 4, for example, 3 7 2 1, multiply this one by 1,000, by 100, by 10, and then I add everything together. I'm gonna get the number. Is that okay? However, sometimes I don't know how many digits I'm gonna get from the user, or sometimes it's gonna be like complicated, or I just want to explain another way. Okay, for example, I'm gonna tell the user, please enter a number, and when you finish, hit enter. So the user can enter only 2 digits and then enter. Sometimes 3, sometimes 4, sometimes 5, and so on. Is that okay? So I'm gonna do also something interesting right now. That's what I'm gonna call it. As you see here, I'm gonna call it like you have running conversion. Very interesting. I'm gonna tell you what it means, running conversion. So as I get a number from the user, I'm gonna convert it. I get another one, I'm gonna convert it. Get another one, I'm gonna running, right? So every time I get a digit, I'm gonna tell you how. Very simple, very interesting. For example, I ask the user, give me a number. The user, for example, give me 2. Okay, is that so? This is the running conversion. Okay, so in the beginning, I'm gonna get 2. So yeah, so the conversion of 2 is 2. Okay, this is the first time. Okay, then the user entered enter 7. You know what I'm gonna do? I'm gonna, the running conversion here, for example, I'm gonna call it R. So the running conversion should equal the running conversion times 10 plus the new digit. Why you are doing this one? It's like when you multiply by 10, you are gonna shift them. So now this one is in the ones. So when I multiply by 10, now it becomes in hundreds. I shifted it so that I'm gonna have a spot for the 7. You get what I'm saying? Very interesting idea. So every time I'm gonna get a number, I'm gonna multiply by 10 to shift everyone. So who was in the hundreds now is gonna go to 1,000 and so on. And now I have empty spot for the new number. That's it. That's what I'm saying, running, right? So anyway, so what I'm saying is that now I'm gonna multiply, as you see here, guys, in the very beginning, I have 2, so I'm not gonna do anything. It's 2, okay? Now I got 7. So what I'm gonna do now, so it should be 2. I'm gonna multiply it by 10 plus 7. So now it is 27. Okay, the user hit enter. Okay, I have the conversion here. I'm done, right? The user didn't hit enter and give me another number, like number 3. So what I'm gonna do, I'm gonna repeat the same thing again. I'm gonna take this one, multiply it by 10 plus 3. So it's gonna be 273, and so on. You understand the idea? Anyway, you have different ways. So whatever easy for you, you can do it, okay? So that's what I'm explaining here. So the first idea, guys, as I told you, if you already know, for example, you have 3 numbers, just multiply every number by the weight and add everything together. Or if you are getting the number one by one, okay, you can make like a running conversion, as I told you, okay? So that's what I'm explaining. So here I have number 1, and then when I get number 2, I'm gonna multiply this one by 10, add the new one. Okay, now I got another number, so I'm gonna multiply here. This is the running part. I'm gonna multiply it by 10, add another one. I get another one, multiply here by 10, and this one, same thing here. I got N4, so multiply the running by 10 and add this one. Okay, so if you look at the conversion here, what I did, the first one multiplied by 10,000, right? Because every time here I multiply by 1, actually I'm gonna shift it from one weight or one position to another position. The last one I got here is going to be multiplied by 1. See, this one multiplied only by 10, which is true, right? So anyway, so I'm not going to go through this code. This is a very simple code. This is just a very simple program. I told you, you already have here these numbers here. They have in the location, memory locations here. And I want to do like running. Honestly, if I already know how many numbers I have, I would make it easier. Okay, so I can just take this one. So this one should be 5,000. How many here? Well, 5, right? So I have to take this one. I'm gonna multiply it by 10,000. Is that okay? Then this one by 1,000, this one by 100, by 10, and then add everything together. It would be easier. Okay. However, this running conversion, it would be interesting if you get numbers from a user one by one. Okay. Anyway, just different ideas. Okay. For how I can do the same thing in C language, same thing. You can also multiply by 10, add, multiply by 10, and same thing in C language. Also, I give you number of functions. You can just use these functions, okay? So let's see what this function here are doing here in assembly. And also we have some function in C. I'm gonna explain right now. But for assembly, we have this function, as you see here, guys. Also, we have 2 for 8 bits, and we have 2 functions for 16 bits. Everyone here has signed or unsigned, okay? So what this function is gonna do is gonna be actually the opposite of this one. So this one is gonna take binary and then it's gonna give you array like this one. This one is gonna take the array and give you the binary. Okay, let me clarify. So as I told you before here, very simple. So this function, number 1, you have to put a number in register B. For example, I'm gonna put 11111111. Also, you have to put the beginning address of your array in register Y. After you do that, just to call the function. The function is gonna start from the location pointed by Y. It's gonna put everything in Ascii, like 32, like this one is 35, and then 35 is going to put 0 at the end. Is that okay? Now you can take the output of this function and put it in the other function. Because I made most of these functions, I made them compatible. So compatible means you can take the output of this one, put this one, just to make programming easier. So the other function, it needs something like that, and then I give you this one. Okay, this one here. So here you have here the decimal number is stored as ASCII code in an array, and this array has to end with 0, right? Just to give me the beginning of the array, and then I'm gonna convert until I find 0, right? So just you don't need to give me how many elements in the array, okay? Just give me the beginning and put delimiter 0, okay? And then, so for example, you have here 32, 35, 35, 0, okay? And then this, so here, register Y. So just to put the beginning address in register Y, and just to call this function, that's it. This function is gonna start from here, from Y, it's gonna do the conversion until it finds 0, and it's gonna store the result. If you select 8 bits, it's gonna put it in register B. If you select 16 bits, it's gonna store it in register D, right? Any questions? Easy, make it easy, okay? One more function I'm gonna explain now is in C language, we have a function, this one called number, as you see here, okay? So what this function is doing, you should have array of numbers, okay? And this array of numbers, you pass this array is similar to what I have just explained right now. So this function should convert array. This array should have ASCII numbers, and just send it to this function. This function is gonna return as the number after it converts it. So I'm gonna give you, I'm gonna show now a program on this, but this is for, yeah. So as you see here, look at what I did here. So PTR is a pointer. I think I defined it here somewhere. It's a pointer. PTR is a pointer, and it's going to be used for buff. Buff here is an array. Yeah, look here, I defined it here. Okay, so I'm going to say PTR is a pointer for this function, for this array, and this array should store, as I told you, the ASCII numbers here. So once you do that, so this one is going to convert, put it in number 1. Okay, guys, I know I explained just different ways. You can just use arrays. You can do the conversion by yourself if you want, and so on. Okay, so I'm going to show now. I'm going to give you more details now. But before I give you more details, I want to tell you now about a very important also function in C language. This one is called get number. Get number. So how this is different from keypad? I'm going to tell you. Keypad is going to give you only one character. Is that okay? What if you want to get a number? Like you are going to tell the user, please enter the PIN code. And when you are done, or enter more than 1 digit. So keypad is going to give you only 1 digit. Okay. In many situations, I need to get more than 1 digit, right? 3725. Okay. And then when you are done, hit enter. So the user can enter number, enter. You got what I'm saying? So multiple digits. So the main difference between get key and keypad is going to give you only 1 digit. But if you want to get multiple digits, so you can use this one very easy, right? So this one actually internally it should use keypad, as you see here. I'm going to use keypad as you see here. Okay. So I'm gonna, and then as I told you, so I'm gonna get numbers from the user, and then once the user hit enter, so I'm done. That's okay. And then this function, whatever I'm gonna get from the user, I'm gonna store it in an array. For example, the user give me 32, so I'm gonna store 32. Give me 37, so I'm gonna store 37 in ASCII. It's not in number, in ASCII. So whatever I'm gonna get for user in ASCII, I'm gonna store it in array, and in the very end, I'm gonna put 0. When you hit enter, I'm gonna put 0. Is that okay? And so what is the location of this array? Okay, it's pointed by Y. That means, number 1, you should define an array in your program. This is number 1, as you'll see right now. You should define an array. Number 2, before you call this function, Y should point at the beginning of the array. So you are telling this function, please function get numbers from the user and put them in this array. Is that okay, guys? Again, what's interesting here, as you see right now, this function, the output of this function, which something like that, is compatible, as you will see right now, compatible with this function. So that means I can get a number from the user and I can convert this number to decimal. And I think this was one question in assignment 5, I guess, when you have for a security, if you have a lock, if you have lock, and you wanna get a PIN number from the user to decide if you are gonna open the door or not. So, and I ask you to multiply convert by multiplication, but still you can use this one, okay, as you will see right now. Any questions? So again, number one, you need to define array in your program. You have a y should point at the beginning of this array. Call this function. This function is going to take multiple numbers from the user, and then it's going to put 0 at the end. Okay, store it in the array. After that, if you have array this way, I'm gonna show something really very interesting, as you will see right now. So if you have array like this one, you can use this array here to convert this Ascii to convert this Ascii to binary number. This number one, or you can send this one to put a string LCD. We used before to display this number in the LCD. Very interesting, because the functions are designed so that I get the output from here, I send it there, okay, to make everything easy. However, there is it's very small. It's not mistake, but it's not, I didn't design it carefully, or it's not big deal. The only difference between this function, put string LCD, and put string LCD, before you call this one, you have to put the beginning address in register X, not Y, right? So here, this function and this function, you have to put the beginning address in Y, but for put string LCD, you can modify it if this bothers you. But anyway, I'm gonna tell you how this function works. So again, look here how it works, guys. Once you call this function this way, number one, you are going to call for sure a keypad as you see here. Now, if you hit this one, means negative. So this is a good thing about this one. You can even get negative number. Okay, so you can get like negative 32, for example, something like that, or negative 2 to 1, whatever. So this is, so you are going to use this one for negative asterisk. So if you hit asterisk, what it means? It means negative. That means I have to put the Ascii of the negative here. Okay. I forget to tell you, if you have, just if you want to learn more, okay, it's easy, not difficult, but let me say it. As I told you guys, if you have here 1 1 1 1 1 1 1, and this number is signed, right? So this should be -1. Okay, how can you convert it? Okay, the way I told you guys, if it is negative, okay, I'm not gonna divide this one. I'm not gonna divide this one by 10, as I told you, right? So you have to get the 2's complement of this one, and then this one should give you 1. And because I already is negative, I'm gonna add negative. This, okay. Now the opposite. How can you do it? For example, if I tell you the number is -1, okay? So if you have -1, so how can you convert it to binary? Okay, guys, very simple, very simple. Number one, ignore the negative. This is number one, okay? Ignore the negative, convert to 1. So when I convert to 1, I'm gonna have 1 0 0 0 0 0 0, okay? And then calculate the 2's complement. Okay, maybe you have another way, but I think that's very easy way. Maybe you have another way. You got what I'm saying? So if you have negative any number, you can just ignore the negative, get the positive version, and calculate the negative. Okay, the 2's complement. Anyway, so here, as you see here, guys, number one, I'm gonna call keypad. As you know, keypad, you are gonna get a number in register A, and then I'm gonna compare it with asterisk. Asterisk here means a negative number. If it is a negative number, I'm gonna go to negative. As you see here, what I did here, guys, in negative, I'm gonna add to the array, to the location pointed by Y, I'm gonna add the Ascii of negative, right? And then I'm gonna increment to Y and go back to get another number. Okay. If not, if not, so now I'm gonna compare the number I got with hashtag. Hashtag means enter. That means I am done. I have to leave. Okay. So here there is one of three possibilities here. Number one, you are gonna get negative. You are gonna get enter. You are gonna get a number from 0 to 9. There is nothing else. Okay. If you give me anything else, I'm gonna ignore it because you only allow it to give me one of these three things. So that's why if it is a negative, I'm gonna come here. Sorry. I think, yeah. If this is in case if it is negative, I'm gonna come here. If it is in case of enter, so I'm gonna come here. In case of enter, that means you are done. Okay. So once you are done, I'm gonna put 0 here in the array because this is a delimiter, and then I'm gonna return as you see here. I'm gonna put 0 and just return. Okay. If not, if it is something else, if you enter something else, I have to make sure what you entered is a number, which means it has to be between 30 and 39. Okay. So here I'm just doing the check here. So I'm gonna compare it to 30. If it is less than 30, what it means? It means it's wrong. Okay, you enter something wrong. Here I'm catching error from the user. Sometimes, you guys, when you write programs, you can put assumptions that the user is gonna follow what. So for example, I'm gonna tell the user enter a number between 0 and 7. Okay, you put assumption. Okay, I'm not gonna check. I'm not gonna catch errors. Okay, sometimes no, you need to check. So this program is smarter for sure, because if you give me here, you are allowed only to give you asterisk, hashtag, or a number from 0 to 9. Okay. However, on the board we have A, we have B, we have C. You may you may give me one of these. Okay. So if I don't catch this error, what's going to happen is whatever I get here, I'm going to put it in the array, right? So anyway, so the way I did it here, I'm going to compare A to hashtag. If it is sorry, to 30. If it is lower than 30, just ignore it. Go to the beginning. Ignore. So I'm not gonna put it in the array. Just give me, I'm gonna ignore it. Give me another number, okay? Same thing, I'm gonna compare it with 39. If it is higher than 39, same thing, just to go back here. Get another one. This number is not, you can write an error message if you want. This is something gonna be too advanced if you wanna write error message, okay? Here I don't write error message. If you give me A, B, C, I'm gonna just ignore it. What you mean by ignore? I mean, I'm not gonna write it in the array. Is that okay? So if you come here, if I come here, that means I am sure the number is between 0 and 9. So now I'm gonna write the number in the location pointed by Y, increment to Y, and then go to beginning again. Okay, guys. Conclusion. Very simple. Look here. You have a function when you number one before. You have to create array, okay? And you have to put the beginning address of this array in register Y. Then call the function. What this function is gonna do is gonna take number from the users until the user hit enter, and all these numbers are gonna be stored in this array. Okay. So just to understand how we can put things together here in this program, I'm gonna use. I want you to understand how these functions are designed to make programming easier. As you'll see here, I'm gonna get a num, I'm gonna get output of a function sent to the other one. Okay, everything will be easy. So here I want to add two numbers. Every number is more than 1 digit. You got what I'm saying? In any programming language, this is something very trivial, right? However, here it's not trivial, right? Because this is low level. So after you get a number, 2727, you have to convert. You have to convert from decimal to binary, right? And then the other number, you have to convert decimal to binary. I'm going to add binary plus binary. The result is binary. You have to convert to decimal, and then Ascii, then display. You get what I'm saying? But because if you're using function, everything will be easy, as you will see right now. So let's go through this program. Again, this program just practice to understand how functions. For this function, I have just explained right now. So number one, as you see here, guys, I'm going to create array, as you see here. I'm going to call it this name, number Ascii, whatever you want to call it. So this should have 5 location, 1, 2, 3, 4, 1, 2, 3, 4, 5, 5 location, as you see here. Okay. And then number one, I have to get the first number from the user. I have to get the first number. Okay. So very easy. That's what I did to get the first number. Very easy, right? All what I did, I put the beginning address of this function in Y. Then I'm gonna go get number. So get number is gonna get numbers from the user until the user hit enter. Okay, and everything already stored here. Everything is stored here. Is that okay? Number two, I wanna display this number on the LCD here. Okay, so I'm gonna clear, as you see here, I'm gonna clear the LCD. I'm gonna and then as you see here, look, this is how I'm gonna display it. So this function this one is gonna make array starting from Y, then end with 0. Then I'm gonna take this array, send it to both string LCD. However, here it has to be X, not Y. Okay, so now you can see it on the LCD. Is that okay? Now, so what I did so far, I just got a multi-digit number from the user. I display it in the LCD. So now I want to convert this number to binary. Is that okay? So how I can do that? Again, as you see here, very simple. Okay, as you see here, it's very simple. Look here, guys. Yeah, this way. So I'm gonna get the same function. I'm gonna send it to this one. Okay. What happens, as I have just explained, this function is gonna I'm gonna take the same array. I'm gonna send to this function. This function is gonna convert it and put it in register B. So now I got multi-digit from the user. Okay, and then I convert it to binary number. It is in register B, right? So now I got the first number. I'm gonna repeat everything again to get the second number, right? So now I'm gonna store this one in location called number, okay? Because this is the first number. As you see here, guys, I'm gonna repeat the same thing again here in order to get the second number, as you see here. Now I got the second number, okay? So now I have two numbers, okay? One number I already put here in the memory location called number binary. The other one now I have just got it right now here. This one is going to put it in register B. So all what I'm going to do right now, so one number in B, one number in a memory location, I call it number. Now I'm going to add these two numbers together. I'm going to get a binary number. I have to convert this binary number to ASCII again and display. You got what I'm saying? That's what I'm going to do. Look here. So here I have to yeah, so here, yeah, that's what I told you here, guys. Here here I have a number. This is similar to what I did before. I'm gonna convert this here. So now it is B. Now I have two binary numbers, as you see here, guys. Now I'm gonna add B plus number. So I'm gonna add them together. And now I got two number. I added them, and the result is in register B. But the result is binary. So now I wanna display the result on the LCD. Before you do that, you have to do two things. Number one, you have to convert this number to decimal ASCII, and then you display it. Okay, that's what I did. So number one, I'm going to use this one here to take the binary number here and convert it to decimal. From binary to decimal is going to be in the array starting from pointed by Y. Okay. So now I have this number here. So I have, for example, if the result is 128, this is the result. So now I have 31, I have 32, which is for sure the result is going to be binary, not. So this is the result, binary. Okay. So this function is going to convert the binary to decimal, 38, and then 0 at the end. Then finally, I'm going to get this one. I'm going to send it to both string LCD. Okay, guys, any questions? Very easy. Just you should understand the concept. What you mean by concept? I mean, what you mean by convert binary to decimal, okay? And decimal to binary, and the idea of multiplying by 10, dividing by 10. This is the main concept, okay? Then you should understand how can you use these functions, because this is how these functions are programmed. If you go inside these functions, you will see multiplication by 10, division by 10, as I have just explained. The other thing I want to do here, guys, I want to show you a program here, just in C language. Here I told you in C language here we have a function, we call it number, as you see here. All what you have to do here, just to give me array. This array, it has ASCII numbers, like for example 32, 35, 35. You just send it here to this one. There is no need to delimiter, to put delimiter here, okay? Once you do that, this one is gonna convert to a number. So this one should be 255, a number, and store it here, okay? So as you see here, the way I'm gonna do it, as you see here, guys, number one, I'm gonna make array of characters here, okay? So this is similar to the array I've just used right now. So every element here should have ASCII, 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 and so on, okay? And then once you do that, I have to send the whole array to this one. How can you send the whole array? Usually what we do in C language, we use a pointer. That's why I'm using here a pointer, okay? And then in order to assign this function, this array to the pointer, I'm gonna do something like that. I'm gonna put the pointer, and then here I'm gonna put the name of the array, right? So now, as you see here, I'm gonna get a number from the user, as you see here, and then I'm gonna convert this number to ASCII. I'm gonna store it here in this one, and then after that, if you give me a number from 0 to 9, so I'm gonna display it on the so every time this is while loop, right? So in every iteration, I'm gonna get only one digit, okay? So so here you give me one digit, okay? I'm gonna put it here. I'm gonna convert it to ASCII code. I'm gonna store it here in ASCII code, okay? And then if it is a number less than 10, okay? So now I'm gonna display it on the 7th. I'm gonna display it on the LCD, okay? If it's not a number, what you have to do here in this program, either you give me a number from 0 to 9, or when you finish, you have to hit E. This is what you should do, either 0 to 9 or E, okay? So anyway, so if this is a number from 0 to 9, so I'm gonna go again, get another number. So I'm gonna come here again, guys. I'm gonna get another number. So I'm gonna put it here in the array. Every time, as you see here, I increment I. So I here like X. So I start from I is equal to 0. I get a number, put it, and increment I. Next time, get a number, put it in the array, the location I, and then increment I, and so. So I'm gonna keep doing it this way, as you see here. So I'm gonna as long as you enter numbers, I'm gonna be just here in this part. I'm gonna keep looping here when you enter numbers, okay? Every time I increment I and put this number in the register here, okay? Then now if what you enter is not a number, for example, it is E. So in case of E, here in this program, I'm asking you to display the double of the number. The number of I enter displays the double. Okay, so the way I did it, guys, but look here, I'm explaining this program just because of this slide. I just want you to understand how can you use number, this function if you want. So here I'm gonna put this is pointer. This is the pointer for the array, this array. So here I fill up the array with numbers in ASCII, and then I put here the pointer. This function should convert it to binary, store it in number. Is that okay? So now I converted it from decimal to binary. And then after that, you can multiply it by 2. You can multiply it by 2 or 3. And you have a binary number, so you can do whatever you want to do, okay? Here, just very simple. I ask you to multiply by 2, okay? And then now, I want to display this number, okay? That means you have to convert again, okay? You have to convert it to ASCII again. But again, as I told you, functions can make everything easy. So all what I did here, I just use this one, write integer or write long LCD, and then I'm gonna put here, just give it binary. It's gonna be converted and display it on the LCD. Again, the reason I'm explaining this program, number one, I want you to understand how can you use this one if you need. How can you use this one if you need? This one should convert the binary to ASCII and display on the LCD. This one here, you should have array. This array should have ASCII for a certain number. Just give me both the array here using the pointer, and this one should convert it to binary, okay? Also here, I'm explaining how can you get numbers from the users until the user hit enter or whatever, and then every time I get a number, because as you know, this is a big difference between, if you just to remember, between get number and keypad. You remember keypad is going to give you ASCII, but get key is going to give you a number. So that's why if you want to make it ASCII, you have to convert to ASCII, as I explained before. So after I explained ASCII, I just put it here in there. Any questions? I think that's fair enough. So again, the conclusion I want to say here, guys, very simple. So you should, number one, if you understood what I explained all this in this lecture, guys, you should understand, number one, what you mean by converting binary to decimal, decimal to binary. What you mean, okay? Number two, why we need it, okay? Very simple. Why we need it? Because we speak different language, right? Microcontroller can speak binary, we speak decimal, okay? So we need a translator, we need to translate, okay? So we need to convert. Anyway, so you should understand, also you should understand the idea of dividing by 10 in order to convert the binary to decimal. You should understand the idea of multiplying by 10, okay? Also you should understand, this is the basic idea, how can you do it? However, to make our life easier, this is my teaching philosophy. I want you to understand how we made it. However, just to make programming easier, you can just use the easy way, but still you should, just in case you want to modify it or to learn, right? I cannot just give you a function and tell you, just use this function and you will be happy. No, sure, doesn't make sense. You should understand there's a concept behind it, okay? So I'm not saying, so I think if I'm a student, okay, I would use functions if this can make programming easier for me, right? So anyway, so also I explained several functions. How can you convert binary to decimal, decimal to binary, and so on. Okay. Now, because I just left several things here in chapter. I almost finished chapter 3. However, I just left several things here. I want to go through them again to see what I missed here. I think I just missed a couple of programs, not too many. Okay. Before I go to chapter 4. Yeah. So here, I think I left here one program. Okay, I'm going to explain it. Okay. You remember when we did alarm? Okay. And then I explained this program where I used a switch. You remember when I used a switch to turn the alarm on and off. Then, so here in this program, I used a switch as on-off for a system, on-off, right? Now, I want to do the same program, but using push button for on-off. You got what I'm saying? So for example, if the system is on, when I press the push button, I'm gonna make it off. So if the buzzer is working, when I press the button, no buzzer. When you press the button, there is buzzer. Okay. So there are two ways to do it, guys. Now you already know interrupts. So the way, if I want to do it using interrupts, the way I have to do it, Ascii should run or should operate the buzzer. So the buzzer is done by Ascii. Is that okay? And then inside IRQ, you know there is one bit, enable bit. Here I can say toggle is an enable bit of Ascii. Is that okay? That's it. So okay, if Ascii is on, the buzzer is on. You can hear a buzzer. Okay. However, when I press the button here, I'm gonna trigger IRQ. IRQ is gonna, if it is on, make it off. Off is gonna make it on. Simple this way. Is that okay? Now I want to show you. Okay, if I want to do the same thing, but I'm not gonna put it in interrupts. I'm gonna put it in the main program. So how I can do it? Similar to what I did here. Okay. Okay. That's what I'm gonna show now. Right now. Okay. So, however, there is a difference. There is a difference between a switch and push button, as I told you before. A switch, if you put the switch in one position, you are going to get 5 volts. If you put it in another position, you are going to get 0. You get what I'm saying? So a switch should have 2 positions. One position 5 volt and one position 0 volt. So you can assume one position is on, one position is off. For example, you can assume this is on or this is off. Okay. So if I want to know if the system is on, I'm going to see what is the volt here. If it is off, what is the volt? Okay. That's what I did here. You remember in this program. So in this program, what I did, I'm going to check this bit. If this bit is clear, is 0, so the system is off. So I'm not gonna go here to run the buzzer. You got what I'm saying? I'm gonna keep looping here until, so here I'm assuming 0 means off. Is that okay? As you see here, guys. So again, I want you to understand this point. This is a very important point, okay? However, the situation is different in case of push button. The situation is different. How it is different? In case of push button, when you press, okay, you are gonna get 0 for a very short time, and then it's 5 volt again. So when you press again, it's gonna be something like that. So that means maybe here the system is on and you have 5 volt. When you press, the system has to be off. Okay. When I press here, I have to be on. So the voltage here cannot tell me if the system on or off. You understand what I'm saying? Very important. I'm going to say it again because this is very important. Okay, look here, guys. What I'm saying is that what is the difference? I want to use one switch for on off, right? So system on or something on off, right? Or if I want to use push button, how it is different. I'm going to tell you how it is different. What I'm saying is that in case of a switch has 2 positions. One position should give 5 volt and the other position should give 0 volt. Is that okay? I can assume every time I find 5 volt here, that means it's on. Every time I find 0 volt here, that means it's off. That's why if you want to know if the system is on or off, ask the voltage. The voltage can tell you if it is on or off. You get what I'm saying? This is in case of switch. Push button, in case of push button, the voltage is not going to help you. Why? As you see here, now the system is on. I press it. So now it should be off. Now I press it. So because every time you press, it's going to return 5 volt again, right? So here 5 volt and on, 5 volt and off. Is that okay? So how can we do it? Now, how I can use the push button? This is very simple thing, guys. And this is actually similar to what you did in many labs, in several labs. Like you remember in the LCD and keypad lab, you remember when you used the variable to tell me the status of the LCD. You remember? Okay. So for example, this variable should have one of 2 values, right? In the very beginning, the LCD is on. So I'm going to put this value. So at any time, if you want to know if it is on and off, ask the variable. It's on. Here is on, right? When you press the button, I'm going to make this one. So anytime, if you want to know if it is on or on, just ask the variables. Now it's off. You get what I'm saying? So now we did it many times. We also did it in the same lab when you used it like to know if it is line 1 or line 2, right? So it's the same thing here. So here, in case of a switch, I didn't need to do that because the voltage, that's why it was only one line. It was only one line here because the voltage can tell me if it is on or off. However, in case of push button, as you will see right now, what I'm gonna do, I'm gonna use the variable. Okay, this variable can have 0, 0 or FF, right? So now, so every time you press, if it is 0, I'm gonna assume 0, 0, for example, on, FF means it is off. So now, if I'm on right now, you press the button, so I'm gonna move to FF and make it off, right? Now you press again. So first, I'm gonna ask you the variable: are you on or are you off? Here, because I'm here, I'm off. So I have to go back to here. Is that okay? Again, you can select any two numbers, right? To assume one number on, the other one is off. However, 0, 0 and FF are good numbers, very good numbers. Why? Especially in assembly, simply because if you want to move from here to here or here to here, you can use complement, one instruction, complement. So you need to check, are you FF to make you, are you FF to make you 0, 0, or are you 0, 0 to make, you don't need to check, right? So every time you want to change the status from one status to another, just to complement, right? That's why I like 0, 0 and FF. Anyway, so I'm going to show right now how you can do that, okay? Also, I want to show here, guys, I told you we have, as I explained before, we have 4 push buttons. As you know, these push buttons are connected to BH0, BH1, BH2, BH3, as I told you. Also, I told you every pin here connected to both, connected to switch, also connected to push button, right? And you have to use one at a time. You cannot use both. Also, I told you, and some of you already made this mistake, okay? I told you, if you want to use the push button, make sure the switch is open, right? Because if the switch is not open, that means you already have 0 here. You connect it to 0. So if you press, it's not going to make a difference because the 0 is coming from the switch, right? So anyway, and again, what I'm saying, guys, when you make your own, don't ask yourself, so why I did this way? Why I put push button and the switch, and I should only use one of them? Why I put this way? There is, for sure, there is no reason for that. The only reason is, again, as I told you, this board is made for education, so they want to put too many things here, right? So, but when you in your capstone, or if you want to design your own project, you don't need to do this way. You need a push button, you can just put push button. If you need a switch, you can just put a switch. Okay. Anyway, so we call this is switch, we call it switch 2. Okay. Why these names are important? Because we are going to use these names in functions, as you will see right now. This one is called the switch 3, switch 4, switch 5. And I think the same names are used here. So if you look at the board, they are using the same names here. Okay. So if you want to know, if you press any one of these, there are for sure 2 ways. One way, you can just check the value of the bit here. If this bit is 0, that means you press, right? If 1, that means you don't press. Okay. Or in case of C language, you just have function as well. Function can make our life easier. So we have function here. I think I put them. Oh, what is it? Yeah, I think it's here. Okay. So we have here several functions. Yeah, here, look here, guys. So like switch. Yeah, look here. We have 4 and another 4. 4 for up, 4 for down. You got what I'm saying? Down here means you press. Up means you don't press, right? So this function should return true or false. So if you press, so this one should return true or false. That's why it's returning true and false, because usually you are going to use them inside F. You put them inside F, okay? So these ones are going to return true if you press. If you don't press, this is going to return false. This one is the opposite. So this one is going to return true if you press. Anyway, so let me go back now and show you what I have just explained now. So here, guys, yeah. So here, this is the idea I have just told you about, guys. So here I'm going to make a variable, as you see here. This variable, I'm going to call it on/off, any name. Okay. So this variable should tell me, and this variable should get one of 2 values here, FF and 0, 0. And here, I just decided to use 0, 0 for off and FF for on. It doesn't matter, for sure, it doesn't matter, right? So anyway, because when I mentioned it earlier, I said the opposite, but doesn't matter. I have just 2 values. It's just numbers, right? So the logic of this number should be in your program anyway. So here I decided to use FF for on, 0, 0 for off. Okay. So I'm going to show how it works. You can see here the code is not as easy as before. Yes, because if I go before here, look, it was just 1 line. Yeah, here it was easy because all what I know, if I want to know if it is on or off, I'm going to just check the bit, 5 volt or 0 volt, right? However, here it's just more complicated, little bit complicated. So here, as you see here, so what I'm going to do here, as you see, guys, number 1. So here I start from here. So here, so I'm going to check this bit. If this bit is high, okay. If this bit is high, okay, that means you are not going to change the status. It's high, right? When I have to change the status, when it's 0, right? When you press. So now if you don't press, okay, that means it is high. So I should not change the status. If it is on, I have to keep it on. If it is off, I'm going to keep it off. So if this is the case, I'm going to go to start. As you see here, guys, in start, I'm gonna check. If it is off, go back to here. If it is on, come here, execute the buzzer, as you see here. Is that okay? Let me say the logic again slowly. Number 1, guys, I'm gonna check this bit. If this bit is high, that means I'm not gonna change the status. You didn't press to change the status. So all what I'm gonna do, I'm gonna come here to check if it is off. So I'm gonna just to go back here to check again. You are gonna keep it checking here, okay? If it is on, so I'm gonna come here, okay? And also, guys, here you can see the beauty of interrupts. You can see the beauty of interrupts here. What I'm doing here is that's what we call booling, as I mentioned before. Booling means you have to keep it checking, okay? In interrupts, I'm not gonna write a code to keep it checking. You understand what I'm saying? This is the beauty. So here the CPU is busy to check all the time. That's what we call booling. Anyway, now what if it is 0? So if it is 0, this branch is not gonna be taken. I'm gonna come this way, okay? So what should I do if it is 0? All what I have to do, guys, as you see here, I'm gonna load this one. I'm gonna complement. I'm gonna put it back here. Is that okay? Complement, because I need to change the status. 0 means you press, so I have to change the status. If it is 0, 0, I have to make it FF. If it is FF, you have to make it 0, 0, right? And this part here for debouncing, so I'm not gonna talk about this part, just debouncing. And then after that, I'm gonna come to check if it is on or off. As if it is off, so I'm gonna come here. If it is on, I'm gonna come here. Okay. So let me write it in another. Just summarize what I said. Look here, guys. If this one is 1, in case of 1, so here I'm gonna come here to check if it is on or off. That's it. If it is off, I'm gonna come back to here. On, I'm gonna come here. Off, on, right? However, in case this one is 0, 0 means I have to change the status. So all what I'm gonna do here, guys, is change the status, okay, by complementing on off. This is just debouncing. After I change the status, I'm gonna come here to check if it is on or off. Any questions? Okay, guys. Okay. The other thing I left here, I already explained the idea of debouncing. I explained it. I already explained how can we. That's what, again, quickly. That's what you are expecting to see something like that. But in reality, that's what happened in reality. Bouncing. Okay, and then bouncing, and again, this problem happens only in case of mechanical switches. Okay, sometimes it doesn't matter much, it doesn't make a difference. Sometimes it makes a major problem. How? I'm gonna tell you how. Look here, look what I'm gonna say. I think most of you in the last test, most of you used the debouncing in IRQ. Okay. However, you don't need to. You don't need to. Why? Because first, what is the problem? The problem is that when I press one time, I'm gonna trigger IRQ multiple times. This is the problem. I should trigger IRQ only one time. However, because of debouncing, it's gonna be considered like multiple pulses. So you have here, like you press. That's what, again, there is no human being that can press 3 times in 20 milliseconds. But microcontrollers don't understand, right? So they just, every time they see 5 volts, 0 volt, 5 volts, especially they are fast. So anyway, so what I'm saying, if I connect this is to IRQ, so what's gonna happen? So I'm gonna have here, for example, 1 interrupt, 2 interrupts, 3 interrupts, 4 interrupts. So maybe you're gonna get 4 interrupts, and it should be only 1, right? However, in the last program, in the test, it doesn't matter. You know why? That's because inside IRQ here, I disable RTI. So if you press 1 time and you disable RTI 3, 4 times, no problem, right? However, if you toggle RTI, yes, now you may have a problem. If you toggle RTI, that means because you press 1 time, it's not gonna toggle, because what happened? Toggle, and then it's on, stay on, right? Because you understand what I'm saying? Okay. So, or if you are counting how many interrupts you have, now you are gonna have a problem because of debouncing. Anyway, so I explain how can you deal with debouncing. I explained the code. Yes, this is the code we used. I can just wait. By the way, maybe 20 milliseconds may be too much. So you can try. Why it's a good idea to you have to be smart, because I don't want to spend, for example, if I read this code inside IRQ, I don't want to spend much time in IRQ. So to make the program efficient, So I don't want to spend much time. Is that okay? So maybe 20 is too much. So you can try different values until you find the smallest values that you can debounce the switch. Okay. The other thing I didn't mention, you can solve the same problem. What I did here, I solved the problem using software. So I used software to solve the problem. However, we can solve the same problem using hardware solution. Okay. What you mean by hardware solution? Very simple. Look at the idea. All what I'm going to do, guys, I'm going to put a capacitor here. I'm not sure if this board, I'm sure the old board is the blue ones, the blue board is the old ones. I'm sure they don't have hardware solution. I'm not sure about this one if they hardware solution or not. Anyway, so the hardware solution, I'm going to put a capacitor this way. You know why? I'm going to tell you why. Very, very interesting idea. So when I put a capacitor this way, it's going to happen, guys. Without a capacitor, I'm going to have pulses this way. So these pulses this way is going to be interrupted like 0 volt, 5 volt, 5 volt, and so on, right? However, if you put a capacitor, what's going to happen is when the switch is open, so the capacitor is gonna charge, right? As you see here, it's gonna charge, as you see here, right? Here should be a pulse here. There is a pulse, okay? So if the switch is open, here it's open, okay? So it's gonna charge. And then because of the bouncing, when it closes, it's gonna discharge this way. Is that okay? So what happens is it's gonna charge a little bit, then discharge. It charge little bit, discharge. You got what I'm saying? So this is charge, this is little bit charge is gonna be still 0 volt, because you know 0 volt has a range. So for example, 0 volt until 0.3 or 0.2 is gonna be considered 0 volt. You got what I'm saying? So if I increase the voltage little bit, it's gonna be interpreted as logic 0, right? So I don't have a problem. So someone can ask me, you are saying you are gonna charge little bit. Are you sure it's gonna, how can you assume it's little bit? Maybe you can charge too much and go too high. My answer is no. Why? Because the time here, usually this ripple has a very short time. So this time is not enough to charge it all the way too high. Anyway, I don't spend much time in this one. I want you to understand, number one, what is the bouncing problem? I think how is going to impact the code. I already explained how can impact the code. Or also I explained sometimes it doesn't matter. It's not going to make big difference, like the last test, right? Sometimes it make a difference, especially if you toggle. If you toggle, for example, IRQ, okay? Because when you press one time, maybe one time is going to be interrupted 3 times. So toggle, okay? Or maybe it's going to interrupt 5 times. Toggle. So maybe if it is on and you press, it's still on, right? Because it was on, off, on, off, on. You got them? So that sometimes it makes trouble. Also, if you wanna count how many interrupts I need for every time I press one time, should be counted as 1, not multiple. Anyway, so also you should understand we can solve it using hardware by have a capacitor like this one, and the idea is that the capacitor should charge a little bit, but still is going to be interrupted as 0 volt. Okay, so in this case you don't need to write the code. The code is used only in case if you want to have a software solution, right? So you don't need to put the code. And if you ask me which one is better, for sure this one, maybe this one is gonna cost you a little bit money for the capacitor, but having some instruction inside, for example, IRQ, doesn't need too much, because if you want to make like super fast or very fast system, you have to spend as little time as possible in interrupts. You got what I'm saying? As I mentioned before, if you again, the worst thing you can do is that you spend too much in one interrupt, because if you spend too much time in one interrupt, this is gonna impact the other interrupts and also the main program. Okay, guys. So anyway, I'm gonna continue next time. Okay. I think I almost finished. Maybe only one slide or so.